Welcome to this particular lecture. We will continue our discussion on the concepts of object-oriented methodology. The next concept that we are going to see is abstraction. Okay. Now, in the last lecture, we have already seen how the code, the data and the code can be encapsulated inside a class. Okay. This enables privacy so that any object from outside the class should not be directly able to access the content of the class, right? So, abstraction is nothing but it is an act of representing only the essential features, hiding the unnecessary background details. Okay, this is basically called as abstraction. So abstraction is nothing but act of representing only the essential features, hiding the unnecessary background details. And this particular mechanism is also called as data hiding. So this mechanism is also called as data hiding. Now, why abstraction is essential? Let us take an example of a car that is being manufactured. Okay. Now, if you want to drive a car, we need not need to know the internal working of a car. Okay, the company has to hide the trade secrets about the car from the customer, and the car manufacturing company only avails him the functionality that will enable him to drive it. So this is basically abstraction. So in simple words, abstraction means for the end user, whatever functions that he needs to use, only those functions names can be given to the end user, and inside background code, which is also a trade secret, which is also a code that end user should not get, such code is hidden from the end user, so that two things happen. One, the code remains secured, and second, for the end user, okay, without going through the programming jargons unnecessarily, he can only focus on what is to be used, right? So this is basically called as abstraction. Now let us see another example. Let's say we have a class called as bank. Okay, now what happens in bank is there are so many information elements which are there when we consider bank. Okay, there are so many customers, so each customer will have account number, then there are customer will also have name, right? Each customer will also have a particular balance against the account. Also, annually bank must be doing some profit, right? Or bank must be having some loans and so on, debts, whatever it is, right? So these are all the things which are part and parcel of a bank, right? Now, for a clerk who works in a bank, okay, he need not know how much profit annually the bank makes or other internal details. For a clerk, he should be only able to know the account name of a customer, customer's name, and the balance, and some transactions related to the customers, right? So in this particular class, if you can see, there is a function that we have written, display to clerk, and only clerk is given access to only these three parameters, that is account number, name, and balance, which are relevant to the task what he is performing. A clerk need not know anything about the annual profit that is made by the bank or any other jargons which he is not needed to know. So this will hide the internal details of the bank management from the clerk, and also it will enable the ease of working for the clerk as well, right? So when you create an object of this particular class, display to clerk function, member function, this function will be available for the clerk and he will be able to access the account number, name and balance. So in general, abstraction means what? Your data and method which are there within the class, okay, or an object, okay, it works as a black box. That means you know what is the information that goes inside this black box, and you can track what is the output that comes out of this particular black box, but you need not know what is the internal working of this particular object. Okay, what you can know is what are the different functions that are available, the name of the functions which are or methods which are available in a class, right? So that the object, the concerned object, can just call those functions and do the work. What is the code within each of this member function is not needed, and it is not shown to the end customer. So this is basically a principle of data hiding, and this concept is called as abstraction. So there are three pillars of object oriented programming, okay, and these three pillars are called as P, I and E, or pi. Now P stands for polymorphism, I stands for inheritance, and E stands for encapsulation. So we can say that these three are the pillars or foundations of object orientation. So whichever language follows these three concepts, okay, or enables these three concepts, that language is an object oriented language. Out of these three concepts, we have already seen what is encapsulation. Okay, now let us see what is inheritance. Okay, now in English, usually when we say we have inherited the traits from our parents, it simply means that we have acquired certain features from our parents, right? So it is basically the act of inheriting certain properties from the parents, right? So similarly in programming, okay, what is inheritance? Inheritance means it is creating new classes from the existing classes, so that the new classes acquire all the features of the existing classes. Okay, so in simple words, what is inheritance? Fine. Now here, although we say all the features, but we can actually control, a programmer can actually control which features can be inherited, which features need not be inherited, right? So let us see a simple example of inheritance. So in this, you can see that you have a class called as bird. Now this class bird, it has certain attributes, for example feathers, property that the bird lay eggs and so on. Okay, so this is an existing class. Now we have new class called as flying bird, and we say that this flying bird inherits the properties from birds, right? So that means this flying bird class will have its own attributes, plus it must have acquired these attributes, that is feathers and laying eggs capability. These two attributes are by default inherited from the bird class by the flying bird class. So what will be the attributes of this flying bird class? Its own attributes plus the attributes which are inherited from the parent class will be the attributes of this flying bird class. Similarly, there is also a class called as non-flying bird class with its own specific attributes plus the attributes which are inherited from the parent, that is bird class. So the total number of attributes of non-flying birds class will be its own attributes plus the attributes of the parent class. Similarly, robin and swallow are two classes which acquire the properties from this flying bird class. So what will be the attributes of robin class? Attributes of robin class will be the attributes of its own plus the attributes, all the attributes which are acquired from this flying bird class, which in turn must have acquired attributes from the bird class. Similarly for penguin and kiwi. So this is an example of how you can have an hierarchical relationship that established between the classes. so that new classes can be created from the existing classes, such that these new classes acquire all the features of the existing classes. Okay, now one terminology that we are going to see. Okay, the class that is existing class, okay, it is also referred to as parent class. In Java, the existing class is also called as superclass, and the child class, or it's a new class, it is also called as subclass. Okay, now those who are familiar with C++, okay, you must be remembering that when I say class A is a inherits properties from class B. Suppose I want to say that class A inherits properties from class B. Okay, then there is a particular fashion of writing it with colon and all. Here in Java, we use a keyword called as extends. Okay, so extends is the keyword that we are going to use for inheritance in Java. So you have an example here. Here you have a class called as SUP. Okay, just a name to show you that it's a superclass. Now this SUP class, it has two member elements, integer variable A, integer variable B, and there is one method or function called as method1. Right? Now why I have written here protected? Basically in Java we have a public accessibility label, you have private accessibility label, and you have protected accessibility label, and you have a default label. We are going to speak about these labels. Just to tell you that whenever you declare any member from within the class as public, whenever you declare any member from the class called as public, okay, the object of that class can access it using dot operator. Now whenever you declare any member of a class called as private, object of the class cannot directly access that method using a dot operator, and then such private attributes can be accessed by the member functions of the class, which in turn should be public. Okay, so if you have private members of a class, then you should have public member of the functions of the class. So public member functions of the class will access that private data, and then object in turn using dot operator will access this member function. Okay, so indirectly will access the private data members. Now we are talking about this third visibility label, okay, with respect to C++. Okay, we are talking about what is protected mode. In protected mode, okay, it simply means that these data elements A and B, okay, they are available for further inheritance by the subclass which immediately inherits it, but they are not available for any other class. Okay, so see, if I declare a variable as protected, it means these variables are available for further inheritance by the subclass and nobody else. Okay, now I am creating a subclass called as SUB, and I am writing SUB subclass extends SUP. Extends is a keyword. So this tells that this particular class, which is called as subclass, it inherits the properties from the superclass SUP. Now since these members have been declared as protected, okay, they are available for inheritance in the subclass as well. So how many members subclass will have? Subclass will have its own private member, that is C, which can be accessed using method 2. Along with this, subclass has also inherited two data members, that is A and B, which will be treated like its own data members. So this is a small example of inheritance. The next concept that we are going to see is called as polymorphism. Now in English, poly means many and morph is to exist. So in simple words, polymorphism is the ability to exist in more than one form. Or in simple words, it is the ability to assume several different forms. Now in C++, we have already seen there is something called as operator overloading, there is something called as function overloading, and then we have something called as virtual functions also as part of dynamic polymorphism. However, in Java, operator overloading concept have been removed. Okay. Now to see that, we will just see an example. Suppose we have a class called as superclass SUP. Superclass houses a function called as void calculate. It receives x as input and it simply prints the square value of that x. So x into x is printed. Then there is a subclass which extends superclass, so it will inherit all properties including this particular function called as calculate. Okay, and what this subclass does? This subclass basically calculates the cube value x into x into x. That's a cube value. Now there is a main class that houses the static void main function, that is polydemo class. In this class we have created two objects. obj1 is an object of the superclass, obj2 is an object of the subclass. Now we are now first creating reference variable. Okay, ref is the reference variable of type SUP. So it is the reference variable of the superclass. Okay, now what we are doing first, we are making this reference variable refer to the object of the superclass obj1. So this reference variable, its type is SUP, and we are assigning to that reference variable object of the type SUP as well. Okay, so right now the reference variable is pointing to the object obj1, that is of the superclass. So since the reference variable is pointing to the or referring to the object 1 of the superclass, when ref is going to call the calculate function passing 2 as an argument, okay, since it is referring to the object of the superclass right now, the calculate function will be called from the superclass. Okay, so it will call the superclass's calculate function. Okay, and as a result, when 2 is passed as parameter here, what will happen? It will simply print, okay, it will simply print square value equal to 2 into 2, that is 4. Fine. Now after that, the same reference variable, note that the type of the reference variable is superclass type. Okay, so the same reference variable is now pointing obj2, that is object of the subclass. Okay, now if ref is going to call calculate function passing 2, it will call now calculate function from the subclass. Okay, ref, since it is now referring to the object of the subclass, when it now again calls the calculate function passing value 2, it will call the function from the subclass, so it will then print cube value equal to x into x into x. Okay, this happens automatically. This is basically the dynamic polymorphism that we were talking about. Polymorphism is automatically taken care of this way in Java. So in general, what has happened is basically you had two calculate functions. The superclass had one calculate function, and the subclass that inherited superclass had its own calculate function as well. What happened is initially we created a reference variable. Now this reference variable was of type SUP. When we made it point to the object of the superclass, that is ref equal to obj1, okay, this it actually ref variable it actually access the calculate function from the superclass. But when we made it when we made it refer to the object 2 of the subclass, ref function ref variable called the member function from the subclass, that is calculate function from the subclass. So this is how it dynamically makes the switching. So this is how the polymorphism is taken care of in Java programming language. This is another example of polymorphism. Suppose you have a superclass called as shape, which has a function called as draw or method called as draw. You have circle, box object and triangle object. These are the three classes which inherit the properties of the shape class. They have their own draw functions. Then whenever a draw function is called, which draw function will be called? It will be based on the reference variable, which object the reference variable is pointing to. So if the reference variable is pointing to the object of the circle class, draw of circle will be called. If it is pointing to the object of box object class, then this draw will be accessed. And if it is pointing to, or if it is referencing to the object of the triangle object class, then this will be called. Okay. Also, students, please note that although I told you that in Java they have scrapped the concept of pointers, but looking at this particular line of code, you may feel that when I say sup ref equal to obj1, is it not storing the address of obj1? Okay, so basically pointers concept have been removed, but internally all this is taken care of by the programming language itself, by the constructs which are there in the programming language itself. So user are not directly given the access of the pointers, but internally there are ways how this pointer concepts work. This is a kind of abstraction which they have achieved. Okay, next concept, a very important concept, is called as message passing. This is also essential concept of object orientation. Seventh concept called as message passing. Okay, the objects, they communicate with each other by sending messages. So for example, this is a sending object, this is a receiving object. An example, suppose I say employee.salary in bracket name. So when I say employee, if employee is the object, then when I say dot salary, this object is calling the salary method, okay, which is localized to it. Suppose there are different objects of type of employee, say employee 1, employee 2, employee 3. There are say 3 objects, say employee 1, employee 2, employee 3. There are 3 objects of type employee. Each of this object will have its localized copy of salary function. So if I say employee 1 dot salary, the salary function of employee 1 will be called, and not of employee 2 and employee 3. So this is how the objects can access the methods. Similarly, the objects can communicate by passing messages in this particular way. So this is a very important concept called as message passing. Now, before we close down this discussion, let me also talk about compile time and runtime mechanisms. In Java. Okay. So in Java, apart from the syntax and semantic checks, one important logical task is basically performed at compile time. Okay, so remember, apart from checking the syntax, the semantic jargons, apart from checking all that, during compile time, one important logical task is also performed, and that is called as inheritance. So during the compile time, okay, inheritance is also implemented in Java. Now, when we talk about the runtime, what is runtime? Runtime is basically the period when syntactically correct program is actually executed in the computer system. That is actually called as runtime. So, during runtime, especially in Java, okay, all such tasks, runtime tasks, they are called as either runtime or dynamic tasks. And in Java, one important task is performed at runtime apart from the normal thing that is happening, and that is polymorphism. So you should remember this. During compile time in Java, inheritance is implemented, whereas the polymorphism is implemented during the runtime in Java. Quickly, what are the benefits of object-oriented programming? The first benefit is elimination of redundant code and extended use of existing classes. Since in object-oriented programming there is a concept called as inheritance, this ensures that redundant code can be eliminated, and if there is a already existing class, this existing class can be extended so that a new class can inherit the property of this existing class. So in a way, elimination of redundant code is possible due to inheritance. Second, object-oriented programming enables building programs from standard working modules that communicate with each other rather than writing code from scratch. So once we have, basically in object-oriented programming, there is something called as abstraction, there is something called as encapsulation. So these objects which are already there, we can simply make them communicate with each other, okay, and achieve the task instead of writing the entire code from scratch. So this is also another advantage of object-oriented programming. Data hiding also helps to build secure programs. Unauthorized people will not be able to see the code. So that is the beauty of data hiding. Multiple objects can also coexist without inheritance because each object will be encapsulated inside one particular structure. They will have all the parameters which are local to them. So maybe there is a class called as mango. You might have thousands of objects of type mango, but all these objects can coexist without disturbing their internal variables, instance variables. Then it becomes possible to map objects in problem domain to those in program. Sixth is, it is easy to partition work in a project based on objects. Since we have the concept of encapsulation, abstraction and so on, because of this we can nicely divide or partition your project or the work based on these objects. You can divide them into modules. Okay, object orientation also enables you to easily upgrade from small to large systems. The software complexity can be also easily managed. Message passing communication technique between the objects, it makes the interface description with external systems very simple. And being a data centered design approach, object oriented approach, it enables us to capture more details of a model in an implementable form. Now let us quickly see the applications of object oriented programming. It is basically used in real time systems. It is used in simulation and modeling. It is used in object oriented databases. It is used in artificial intelligence and expert systems. It is extensively used in neural networks and parallel programming. It is used in decision support and the office automation systems. It is used in CAD, CAM systems, and it is also used in hypertext, hypermedia and expert text. So this was a brief introduction about the object oriented paradigm. Thank you.